Today we're going to look at 1994, question 3, part A. Now, it's a nice straightforward question. We have a little ball that's kicked from this point here, we'll call it O, up and down, and lands all the way over here at a point they call O. We know that's 45 meters along the x direction, and we know that it goes to a maximum height of 22.5. Again, watch your numbers, that's half of 45. We'll see if that's relevant later on. We are going to call our initial velocity components Q and P. So what we're looking for here, just to find here, is the values of Q and P, and then part 2, the furthest this person can be from O when they're running at 7 meters per second. So we'll worry about all that later on. Okay, now what we're going to do in this question is use our position vectors. So just in case you're not used to these ones, we'll just do a quick aside to velocity vectors and a position vector. If you know what these are, feel free to skip ahead until the other page comes back. Now, a velocity vector is v in the x direction I plus v in the y direction j. All right. If we set our u equal to pi plus qj, like they are in this question, and we have gravity okay, so how do we actually figure these things out? Well, using the equation v equals u plus at, we can sub it back into here. All right, so a velocity vector, well, v in the x direction is going to be p is the actual velocity, and there's no acceleration, so that is going to end up being pi. If we look at what's our velocity in the y direction, okay, a little more complicated, so we'll write this one out. Vy is q minus gt. All right, so we have q minus gt in the j direction. So that is our velocity vector, the velocity at any particular point in time. Okay, it's always going to move in the same in the x direction, and that's how we're going to calculate it. So it's a nice way to kind of contain it in one place. In a similar way, the position vector, which is usually written as or, okay, is the position in the x direction and the position in the y direction. Now, the way we're going to figure these guys out is using the equation s equals ut plus a half at squared. So sx is pt plus 0, so that's fine, that's nice and easy. Sy is a little bit more complicated. Qt, taking my q from up here, minus g over 2 t squared. Okay, so popping that in here, our position vector just brings all this together in one place. It's pt as our I component plus qt minus a half gt squared in the j direction. There we have it there. All right. Again, strictly speaking, you don't need to use this, but it can be a handy way to tidy it all up in one place. And coming back to our question, let's lay out our velocity and position vectors here. So our velocity vector equals vxi plus vyj. So that means it's going to be pi plus, let's just do that on the side, v equals u plus at, vy equals q minus gt, just so we know it. Q minus gt, j. Now, our position vector, or is sx plus syj. And that equals, using what we've done before, again using our s equals ut plus a half at squared. That equals pti and then we have qt minus a half gt squared j. Okay, so these are the two little things we're going to use when we begin to split apart what we know in this question. Okay, so point 1 we're going to call m, which is our maximum height. So we'll say at m, well, what do we know? We know that sy is 22.5 and we know that vy equals 0. All right, so we can begin to put these into our equations. Let's look at them one by one. This looks simpler, so we'll start with this one first. So vy is the y component of the velocity. Q minus gt, and if that equals 0, q equals gt, and t equals q over g. These are really annoying to draw because they're so similar as letters, but just mind yourself and keep it tidy. So, first little bit of it. Second little bit, so we're going to come all the way up here. And we are going to say, we'll just box that off so we don't get all confused and messy. Sy is 22.5. And that equals this part of the equation here, qt minus g over 2 t squared. Sub in t. So we have 22.5 equals q by q over g. Now I'm just going to be careful, I'm going to write this a little bit carefully. It's tempting to jump ahead, but then we'll run the risk of making a small little slip. Minus g over 2 by q over g, all to be squared. Okay, tidying this up, 22.5 equals q squared over g minus, I'm going to run another line on this one just to be sure, q squared over g squared, and that is going to be 22.5 minus equals q squared over 2 squared, and that g are going to cancel, and I end up with q squared over 2g. Okay, so we can actually work these ones out, and we can see that this is, of course, sorry, that's g there, whoops. We multiply that above below, we get 2q squared over 2g, so 22.5 is going to equal q squared over 2g. All right. Rearranging here a little bit, that means q squared equals 45g. So q equals the square root of that. Now it's worth just taking a little moment sometimes and checking, is that a nice number or is it a horrible number? 45 by 9.8 is 441, which is a reasonably nice looking number, and let's just check that, and it's a square for us. So this is going to be nice and tidy. So q squared equals, we'll write it out for the examiner, 441. So q equals 21, halfway there. Now, let's go up here and we'll look at our other point. We're going to look at the point or. So we know at or, well, what do we know? Sy equals 0. If Sy equals 0, then this component here is 0. That is qt minus g over 2t squared equals 0. You can see straight away that one of these is going to be a 0. So let's divide by t. T equals 0 is obviously one of these points. So we will say that q equals g over 2 by t. Okay, so we've divided out one of the t's. Rearrange that a small bit. And we're going to find that the t here. Call this t2 just so we don't have any confusion with earlier on. Okay, t2 is 2q over g. Now, the other thing we're going to need to know with this one is Sx. Okay, Sx equals 45. So where's our component? There it is, pt. So Sx equals 45. Therefore, pt equals 45. pt2. Let's sub this in. Now I'm seeing G's and 45, so with any luck this is going to be reasonably tidy as we go through it. So we're looking for a value for P here. So P is going to equal 45G divided by 2 and divided by Q. Alright. That equals, we'll go across because we're running short in size. 45G we know from before is 441. Q is 21, so that's 42. Can we just do a little bit of a check and see, is this a nice tidy number? 441 divided by 42, 10.5. So P equals 10.5. And there we have P and Q. Now, part 2 of this question looks a little bit horrible. How far can someone be if they can run at 7 meters per second? And actually, this is quite a nice, tidy piece. We're even going to be ambitious and see can we squeeze it in here. All right. So we want to know furthest distance from ore that a person can be. So how far back can they be if they can run at 7 meters per second and arrive just as the ball lands? And the key thing is the total time they have is the time it takes the ball to land. So time equals t2, and that up here is 2q over g. We know q is 21, and that is 42 over g. Alright, they have that in total time to do it. They are running at 7 meters per second, so therefore max distance is the speed 7 by 42 over g. Pop that in my calculator. 7 by 42 divided by 9.8, 30 meters. There we are. Okay, sometimes they look weird, don't be afraid of them, just lay out what you know and it might pop out very easily.